Okay, so hopefully everybody can hear me. If not, please type in the Q&A link. But welcome to the second live online coding session for this 6.00.1x edX class. In this session, we're going to be writing a different program than the one from yesterday. And the program we're going to be writing is let's see. So the program we're going to be writing is going to be related to bisection search, which hopefully will help you in problem set 2, which is due on Wednesday. And in this, the specifications for this program is that we're going to be given a linear function. So this will be just a Python function that we're going to define ourselves, but we can, in the future, we can even have someone else give us the function. And the things we know about this function is that it's going to have a positive slope, and it intercepts the x-axis somewhere between 0 and 100. We're not exactly sure where. And we'd like to use bisection search to find the point where the line intersects the x-axis. So we can easily find this number just by solving for x in an equation. But for the purpose of writing this program, we're going to use bisection search. A couple of things I'd just like to start out with before we read the program is just to mention some things that we learned from the previous coding session yesterday. Please be aware that there is a delay of possibly up to 2 minutes between the time when I speak and the time when you guys can hear me. So if I'm late in answering your questions, that is why. And the other thing is you might have choppy video, and if you do, don't despair. The videos will be available to rewatch as much as you want on YouTube after this live coding session. All right, so back to our program. I mentioned yesterday that one of the first things that I like to do when I'm given a task is to draw a picture of what I have to do. So let me start by screen sharing my favorite program, Paint, and there we go. So hopefully you can see that. And let me get my pen. So I'm going to just reread the specs, and I'm going to just draw a simple picture of what a sample line might look like. So let's see. We have, oops, brush. All right, so we'll start with black. So we have a plot. These are our axes, y and x. Oops. And we can assume we have a line like this. This is going to be our function f of x. And this point here is 0. And let's assume that this point here is 100. And what we want to do is use bisection search to find this point here. So we're not sure what that is. We can solve for it, but let's use bisection search instead. So how would we go about this? Let's use blue. So we go about this by, if we remember bisection search, we start out at our low and high endpoints. So we start out here and here. And we're going to take the midway point in between these two. And at this midpoint, we're going to ask, is the value of this function at this x value, so at this value, is the value, so if we call this a, the value up here is f of a. So what we're going to ask is f of a equal to 0? And f of a is equal to 0 means that we have intercepted this x-axis because its height is 0. If it's not 0, then we're going to go one step further and say, is f of a greater or less than 0? And depending on which one it is, we're going to either change our high endpoint or our low endpoint. So if f of a is greater, then that means that we're at this case here where we have to keep decreasing our value, our a. So that means we have to reallocate our high bound. So we want to change high. And if f of a is less than 0, then we want to change the low bound. And basically, we're just going to keep doing this over and over again. So already I can think of, I might want to have a loop in here because I'm going to be doing the same procedure over and over again until I'm sufficiently happy with f of a. So change it back to blue. I'm going to say something like repeat until f of a equals 0. Or according to the problem specifications, or f of a is less than some epsilon. Less than some epsilon value, which means we've reached enough convergence. Okay, so this is how I'm going to think about this, and I'm going to just keep this drawing on the side so that I can refer to it when I'm writing my code. And I'm going to switch to Canopy now and start writing my program. So let me screen share Canopy. Like that. Okay. And now in Canopy, I'm just going to create a new file, and I'm going to call it, what was the name I called this? Intercept bisection.py. Okay, so we can see here I have the file, and I'm going to open it. So just like yesterday, I'm just going to quickly copy and paste the comment of what the program is supposed to do. like that, and just some comments. Okay, so here I'm going to have, I'm going to be given a function. So this f of x is a function, just in regular math terms, it's just a function of x. And I can just translate that just as a simple test function that I'm going to use as I'm coding. So def f x, and this simple function will just return some, let's say, -5 plus 2x. And already I've made a mistake, so it seems like I've forgotten the times, so yes. So I've defined this function f of x, which just returns -5 plus 2 times the value that I give it, x. Again, I can name this function whatever I want. I can name it g, I can name it func, fun times, whatever I want. But I'll keep it simple and just leave it as f. Okay, so this will be my test function that I'm going to use to test my bisection algorithm. Now, I have to actually write my algorithm, and I think that what the code that I'm going to write is going to be useful in the future, so I'm actually going to define it as another function. So I'm going to call it intercept bisection. And to make it a useful function, this is actually going to take as parameters 2 things. The first will be some function f, and the second will be some sort of level of convergence that I want. So in this case, I'm just going to call it epsilon. And again, I can call these arguments whatever I want. Just to make things more clear, I'll just call this func and epsilon. And to remind myself, I'm going to write a comment here. So this is function that computes x-intercept using bisection, and I can write a doc string that says func is a function and epsilon is some small float. Okay. Now, this will be my function, and I can start by first defining what we said our low and high endpoints are. So according to the specifications, I said that the user, that we know that the intercept will be somewhere between 0 and 100. So we can create some variables, say low equals 0 and high equals 100. Okay, so these will be my low and high variables. And the first thing that I'm going to want to do is calculate the middle value. So we can say mid is equal to high plus low, oops, I forgot parentheses, divided by 2. All right, so this will be my middle value. And I'm actually going to screen share my whole screen because I actually have on the side the picture that I drew, and it's pretty helpful to just take a look at that once in a while. So let's see. Screen. Okay. So we can see here on the side, I have the picture that I drew, and on the right side, I have my code. So it's I can't stress enough how useful it is to just have some sort of visual representation of what you're trying to code as you're coding. So I really like having this. Okay. So I've found my mid. Now, as I was drawing my picture, I had realized that I might want to have some sort of loop that goes around, that iterates for different values of mid as I'm recalculating this mid value. So I know I'm going to want some sort of while loop, but I'm not sure what I want in there yet, so I'm actually going to just write the skeleton, and I can write a comment myself, figure out what to put in condition, and I can do something like to do. So while something's happening, what am I actually checking for? So I was actually checking I want some sort of if statement. So I want to say something like if f of mid, in this case my mid is my a, and I can even make a note to myself here that says a equals mid, just for the future. So I can say if f of mid is greater than 0, then what happens? So if f of mid is greater than 0, then that means that my line is still above the x-axis. So I need to go farther left. So I can say something like, I can say high is equal to mid. So I want to reassign my high. Is that right? Or low is equal to mid. Try like this. If f of mid is greater than 0, then I want to reassign my low. And else f of mid is less than 0, then I want to do the complete opposite, so it's reassign my high. Okay. So let's just think about this a little bit more, because this is just the tricky part to figure out when you have this function. But let's look at our drawing. So if f of mid is greater than 0, we are up here. Colors. We're up here if f of mid is greater than 0. So I want my new interval to be between what was the old low and a new high. So yes, I did it wrong. So actually I want to reassign high is equal to mid. Right. And looking back at my picture, if my f of a was less than 0, that means it's down here somewhere. Then my new interval is going to be between here and here. So that means I want to reassign the low. Yes. So like that. So I actually had it wrong the first time. Okay, so that should be okay. And so this while loop is going to keep going on. And then what I want to do is when the while loop finishes, I just want to return the midpoint. Okay. So now I can go back to my to-do here and figure out what exactly I need to put in my condition. So in my condition is that I want f of mid to be sufficiently close to 0. So looking back at my image, I want my f of mid to be down here somewhere so that it's 0. So I want to find the mid such that f of mid is equal to 0. So my condition will be something like while f of mid is greater than 0, then I'm going to want to keep looping. And when it's reached 0, then I'm going to stop. But the problem itself stated we want f of a to be 0 to some certainty epsilon. So actually I don't want to find exactly the 0th point. I just want it to be sufficiently close. So I'm going to change this slightly and say if f of mid is greater than epsilon, not greater than 0. Yes. So I'm going to save my program. Okay, so I think we can try to run this. Now, the tricky thing about this program is this function here that we're giving it as an argument. And we're actually giving it another function, which it's not super common to do. So when we run it, we can print intercept bisection, and we can run it with whatever function we want. So, you know, in a program, I could have had something like this, where I have many functions defined, f, g, h, you know, like 0.08 or something like that. So I can have many functions, and when I call intercept bisection, I can call it with whatever function I want. So I would just basically give the function name. In this case, I'm going to pick f, and the epsilon that I want to find is I want the answer to some certainty like 0.1, for example. I don't want exactly 0, but let's just do something that won't take that long to calculate. And y is, yeah, so it seems that I spelled it wrong. Yeah. All right, so I spelled my function wrong. Okay. So we can try to run it. And let's run this with these arguments, and let's see how it works. So it's going to show up here. Okay, so you can see that it didn't really give me a result yet, which means I've entered an infinite loop, not surprising. So I'm just going to restart the kernel to quit out of that infinite loop. So I have some issues here. So as usual, when I have some issues, I'm going to just start out by printing some intermediary values. And since I have an infinite loop, the best place I can print some stuff is inside my while loop. Okay, so let's print, let's see, what values are important. Maybe the low equals, oops, low, and then we can print high equals, and I think, yeah, someone mentioned that I might have I might need some absolute values here, and I think you're probably right. Let's just figure out what this other issue is. But that's actually a really good catch there. And yeah, let's just start printing out to see what's happening here. So high, and so low and high, and I'm also interested in mid, I guess. Those are the three important variables. Okay, so inside my while loop, I'm going to just go ahead and print these out and run it. Okay, and let's restart the kernel. So what do we see here? We see that my values never really change. So I have my low is 0, my high is 50, and my mid is 50. So I feel like maybe, okay. I actually didn't reassign mid anywhere, which is a bad thing. Okay, so once I've reassigned my high and my low according to what they should be, I actually need to recalculate mid before I go ahead and check f of mid again, right? So what I was doing, I was just checking f of the same mid over and over again. So I need to reassign mid to what I had before, so high plus low divided by 2. Okay, so that's actually a really big problem that I had in my code. Oops, plus. There. Okay. So now let's run it again and see what we get. Cool. So that seems to have been one issue there. Now, so now we can see the iteration. So we have low 0, high is 100, mid is 50, but this doesn't actually look right yet. Let's see. Then we go 0 to 50 to 25, 0 to 25 to 12. Okay. So something's wrong with my division here. So 100 divided by 2 is 50, 50 divided by 2 is 25, and 25 divided by 2 is actually 12.5, not 12. So it seems like I made the mistake of not doing floating point division and just doing integer division. So you might have, I've encountered this before, you might have encountered it as well. The problem in Python 2.x is that by default, when every one of your values is an integer and you're doing a division, it won't include anything after the decimal point. So it actually does integer division, not floating point division. So the way to solve that is to either cast one of your value, only one of the values in the expression has to be a float. So one easy thing we can do is just to put 2.0 like that there. So that should be okay. We can run it again. 1.625. So that might be okay, but oh, I just noticed that I have it there too. Yeah. Okay. So now I seem to have my floating point divisions all aligned, all in order. And I can test with more precision if I want to just do a couple other tests. So that should be okay because it's 1.5625. If I do some random value 2.77, we can run it again. I see. So I think that shouldn't, yeah, I think that's a mistake there. So let's see, what else do we have? We can run it with F, we can run it with G as well. Let's see, what does this do? Huh. Okay, so it seems that there's actually another error, and it might actually be the as someone mentioned before, I think we might actually need this absolute value here, and that might fix it. Yes, that's correct. Okay, so yeah, so this absolute value here, another important thing to remember when you're dealing with bisection search and trying to figure out whether or not you're close to a particular value. So what ended up happening is, looking at this code down here, at the results down here, is when we ran it with G, so actually I'm going to draw something on the side here. Zoom in. And this was, I guess this was the issue. So we have our plot like this. This is 0, this is 100. And the midpoint is 50 here. And let's say our line was like this, something like that. Very, very a not steep line. What happens in bisection search is, first we're going to look at this value 50, and we're going to find f of 50, and we're going to check if this is greater than epsilon, and this is f of 50, and f of 50 is actually less than epsilon. So what we're trying to do is we're trying to get to some sort of convergence where it doesn't really matter if we're positive or negative. And if we choose the wrong thing, then we're going to start going in the opposite direction, and we might enter an infinite loop depending on what the function is. So that's why the absolute value is important, just like that, in the epsilon. So you can see here that we ended up with 1.56 instead of the correct value, which is 1.8. And in this problem, you can even double check whether the value that you're getting is correct. So you can just solve for x yourself. So you can do something like, f of x equals -5 plus 0.08x, and then the place where we intercept the axis is where this is 0, and we can just solve for x is equal to 5 divided by 0.08 in this case, and that should be, if I get out my calculator, is that right? Should be right, 62.5. Yeah. So the x-intercept should be 62.5, which is actually not what this function is giving me yet. So I think there might be another bug somewhere. So let's double check. Let's take a look. All right, I'm still thinking. Let's see. Let me share just the editor for now while I draw some things. So first, we start low with 0, high is 100. The x-intercept for this function should be, just according to calculations, about 62. And the first, so just looking at the trace, the first thing I check is 50. F of, oh, I see. There it is. So the function I'm actually using is called func, not f. So when I use f, it's actually just using hard coding essentially this function f here. So that should be func right there, and that should be func right there, and that should be func right there. And is there anywhere else? I don't think so. So that should actually be more correct. So that's why I think things worked well with when I ran my program with F. You know, things were as they should be. But when I ran it with G, that's why I got the same results. So now that I'm actually using the correct variable name called func inside intercept bisection, now that I'm using this correct variable name, that means that any function that I passed into it here, G, F, H, you know, foo, bar, whatever, baz, those are pretty typical names for functions in computer science. Those will get translated into this variable func. So now func will stand for whatever function I give it. Okay, so now if I run it again, I should get the actual value, which is 62.5 with this new function g. And if I run it with f, just to double check, it should give me 1.8, which it does, and that's the correct value for that. So, and then if I change my certainty 0.1, again, that's, I think, correct. I guess there was a question that says, what if f of mid is equal to 0 exactly? And we don't have a case for that in the function. If f of mid is absolutely equal to 0, if the question is, what if when we first pick, so if we first pick, let's see. So is there a function which satisfies that condition? And we can come up with one. So we can say def h of x. So let's create a function that meets the axis exactly at 50, because that's the first midpoint. So that should be something like -50 plus x. I think that plus x. I think this function intercepts the axis exactly at x. So if we call that with h in here, it does reach exactly 50. If we choose our epsilon to be 0, I think that should also work. So in this particular case, if we have a function that on the first shot, if we get it correctly, where it intercepts when we first calculate the mid to be 50, and we want our epsilon to be 0, well, if mid is equal to 50, absolute value of function of mid is exactly 0. And in this case, 0 is not greater than epsilon. 0 is not strictly greater than 0. So we don't enter the loop, and we just return 50 here. So it works in that case. And the same thing is if we picked some other values here of epsilon. Now, correct, what if in the future, when we do some calculations inside the while loop, what if we encounter the case where f of function of mid is exactly 0? Well, that's also okay because 0 won't be greater than epsilon, and that means we've encountered the exact value that we'd like. So we would just this while loop, this condition wouldn't satisfy anymore, and we would just exit the while loop and we'd return the middle value. So I think that would also be okay as well. Let's see. I'm going to take a quick look to see if there are other questions. Why did we use the func as an argument? So why did we use func as an argument? Well, so I wrote this function intercept bisection to be useful in the future. So for it to be useful in the future, I decided that I would allow anyone who would use it in the future to give it whatever function they wanted, as long as it's a linear function that would intercept the x-axis between 0 and 100. So those are my conditions for it. And to make it a more versatile function, I allow the user to give it any sort of stopping condition leniency, so through this epsilon. So I could, if I wanted to, hard code this function, as I did earlier when I actually made the mistake. And I don't need to have this variable here, so I could just delete it. And inside this intercept bisection, I could just call whatever function I'd want directly. But then the problem would be that how many times do I call the function? 1, 2, 3. So if I ever want to modify my function, or whatever function I want to test, I'd have to change it in 3 different places. So that might be a little bit tedious, and I might make a mistake in the future. So I actually just ended up hard coding the function inside as an argument. So just as, I guess, sort of good coding practice. So now I can just go back and maybe write some code in my comments just to, while it's still fresh in my mind. So check if either, or remember to take absolute value of f of a or x or whatever. Here I can delete my debugging code. Here I can say something like case where guess was too low. And here it's guess where case where guess was too high. And here I can say something like recalculate guess with mu high and low values, and that's pretty good. Commenting just to remind myself what I've done. Let's take a quick look to see if there are any other questions. What is the difference between doc strings and the hashtag comments? Yep, so that was answered. I think if there aren't any other questions, I think we can end here. So hopefully this was helpful. In problem set 2, you will be doing this bisection search algorithm to figure out credit card debt. So that will be a little bit more complicated, but I highly, highly, highly recommend that you draw it out. Just do a simple drawing. It doesn't have to be super artistic. Just draw something simple of the values and what you're trying to find, and I guarantee that it will help you think about the problem better, and it will also give you an outline that you can use when you actually write the code. And if you want to try maybe writing pseudocode or comments before you even begin to do the actual coding, that might even be helpful. So you can say something like, you can create pseudocode that says, create a while loop and figure out the condition later, and then you can say something like how to change the upper bound and how to change the lower bound, and then recalculate. Because if you don't write your outline, then you'll go into the case where you forget to do something. So in this case, way at the beginning when I wrote the code, I forgot to recalculate my mid, which is actually a pretty simple mistake to make, and because you're thinking about a bunch of other things to do. So thank you all for joining me, and I can answer further questions in the forum or through the comments here. And as usual, this video will be available afterward on YouTube, and I'll post this code that I wrote as well on the edX website. So thanks for joining.